All right, should be live now. Okay, so good morning again, everyone, and welcome again to our monthly query progress update, where the goal is that we discuss the progress of our query research within our KNoWS query team. So our high-level goal is to highlight the complexities for reading and writing for application developers that want to work with decentralized data. And within this team, we have these people here doing research in this topic. Not everyone is here today because they're summer already, or almost summer, so some people are on holidays. So we have a slightly smaller delegation. So this is the format of this meeting. So we have around 3 slides per researcher. In the first slide, we talk about the high-level goal, then accomplishments of the last month, and then targets for the next month. And then afterwards, we have a short discussion in the whole group about these topics. And before we start, we have a special guest today. We have Lado from KU Leuven, who will be talking today about his work on Kolibrie, which is a new query engine, a new SPARQL query engine implementation that is implemented in Rust. So yeah, I'll briefly stop sharing my screen here, and then Lado, we can go over to you.
Yes, hello. Just a second. I will share the screen. I hope that you can see.
Yes.
Okay. So hello again. My name is Volodymyr Kadzhaia. My short name is Lado, so I guess it's easy to pronounce and to remember. I'm together with Peter Bonte. We both decided to present you the Kolibrie. We are from Department of Computer Science in KU Leuven. The campus is Pullac in Belgium. So yeah, my topic and research basically is neurosymbolic stream reasoning, and we are working on Kolibrie. So this is what I will show. So what is Kolibrie? Kolibrie is a neurosymbolic stream reasoning engine, and the main idea was for us very simple. We want one declarative system where we can combine SPARQL, querying, rule-based reasoning, RDF stream processing, and machine learning prediction into one framework. And the motivation comes from different domains, but here we will show one of the motivation, and it was part of ESWCC conference also, the fraud detection. So imagine that we have continuously generated data that continuously comes to us. It can be from different sources. It can be sensor, it can be a transaction, or some events. And what we want to process it. And the goal is not to detect something suspicious or dangerous, but also to explain why the system made that decision. For example, in fraud detection, a transaction may be suspicious because of high amount, unusual velocity, merchant risk, or because machine learning predicts a high fraud probability. And the challenge, as I said, is not just a prediction. The challenge is a continuous, explainable decision-making over heterogeneous streaming data. And as I said, the same pattern we found in other domains, not only in the fraud, in smart manufacturing, fintech, smart cities. In all those domains, same problem. We need something where we can explain why the system made such decision, as well as to process continuously generated data that can be heterogeneous, contain different formats, text-based, audio, image, and everything must be processed. Thus there's three core challenges that we found. First, the data is continuous. RDF streams do not stop, so we cannot simply run a static query again and again from scratch. Thus, we need sliding windows and incremental processing. Second, data is heterogeneous. In real system, not everything is already a clean RDF triple. And we may have sensor values, images, video, or time series data. And these need to be integrated into the same reasoning pipeline. And third, rules and machine learning each solve only part of the problem. Symbolic rules are explainable and good for domain knowledge, but they are weak for uncertainty and prediction, while machine learning models are strong for prediction, but they are often black box. And thus, we have the Kolibrie that sits in this intersection. The architecture of Kolibrie is very simple in a way that it's like a Lego. You can choose any parts. It's not like everything monolithic by the architecture. It's some sort of as a microservice, so you can choose any workspaces because in Rust everything is as in a workspace. So you can, if you need, for example, something related to symbolic rules, you can use it without touching, for example, RDF or machine learning. Or if you need everything, querying, you need reasoning, you need also machine learning, as well as stream processing on top, for example, then it's also possible. So the idea is that you can play around. Depends on the task that you have. So a little bit of background how you can define everything in Kolibrie. For example, for streaming, we're using SPARQL, and yes, this is the syntax is the same. We didn't change anything, so we support RStream, iStream, and DStream. In this example, we created a 5-minute sliding window over the transaction stream, and each 30 seconds we shifting. This is the rules how we creating. We have this rule syntax. It's a rule-based basically syntax for the symbolic rules. Besides writing on our rule syntax, it's possible also using M3 logic, and we support. Currently, it's not full supported. We are working on that, but yes, it is possible. Here in this example, what we doing is that if velocity as well as the amount is higher than our threshold, then we're saying that transaction is in a high risk, and the construct is basically the sort of a conclusion, and the if statement is the where clause. I think this is a really good syntax because we are close still to this to the SPARQL, so we are not reinventing completely different So we're staying and focusing on that, and for the community, it can be really, really good. The next is machine learning, and the idea for that we are using ml.predict plus. It's a operator, and the idea was to bring your own model principle. So you have already a pre-trained model. It can be defined by TensorFlow, PyTorch, Sklearn, any popular Python frameworks, and you can this pre-trained model put into the machine learning and basically execute. Here, what we are doing is we creating this, using this fraud predictor model, and we extracting the features from the RDF and feeding our model, and then it will be trained. The most important is the output. Here it's the score, and this output will be presented as RDF triple, which is really cool, because then you can use this output, for example, in another rule syntax, or for example, in query if it's needed. So this is a really nice and elegant way, I think, to use and basically to work with that. In ESWC, I said that we don't have learning part. Now we have, and it's possible now inside of our engine to create your own model. And this is the way how you're doing this. It's the same way as you're doing in the Python, where you're creating your model architecture, you're using, you creating your labels, and then you train basically how many you need, for example, what optimizer you need, batch, epochs, and so on. So basically, and the model will be then the bin file, and this binary file you can put into the ml.predict. So basically, it's you staying inside of our engine. You don't need to use other frameworks or creating a bridge. Everything is in Kolibrie. So now it's possible, yes, to train. So we have the model that declares the neural architecture and output. Then we have neural relation. It's binding RDF graph patterns to model features. And the train neural relation that connects label triples, target predicts, loss optimizer, epochs, and batch size. And yes, after that, you can put it, as I said, into ml.predict. Then this output you can use into the rule or somewhere else, which is really, really nice. So for the months, what I did, a couple of months, I worked basically on this learning part that I showed, that we have a little bit on querying. We finally have named graphs, not fully supports. Now you can create, but it's not possible to insert something or to delete. This is for the next month, our plan. Yeah, this is what we worked on mostly on the learning part. A little bit touched querying because our team is not very big, so it was hard a little bit for me to cover and to support everything. For the next month, and ideally in what this is the priority, it's not like I'm covering all those four. It will be a bit impossible, but for the priority is for full support of named graph, full support if it's possible SPARQL 1.1, because we still not support. We don't have blank nodes and some other keywords that must be, but we don't have yet. And this is top priority for us. Besides that is the part of the incremental evaluation. This is also in our priority. And finally, to do some benchmarks and next paper to show basically to show how in terms of the SPARQL engine, how everything works, and basically compare with other existing tools that we did before, but not we didn't touch maybe. So yes, so what is Kolibrie? As I said, it's one declarative engine, and it is finally the one engine where we combined streaming, rules, machine learning into more explainable by construction. You can also join to our Discord community if you're interested. We are welcome, everyone. Yeah, I guess that's it from my side. Thank you.
All right, thank you. Very nice presentation, a very nice work as well. And I'm sure there will be many questions. I see Fabien already raised his hand.
Yes, thanks. Very nice, very interesting initiative. Can you hear me well?
Yes.
Okay. There is one thing I didn't understand at the beginning, but maybe I missed it in the syntax. So I saw you had the different types of windows and the way you were handling them. What I didn't understand is how you make the difference, and if you make the difference between the static and the stream part in your data, and how you actually, for instance, if I understood well what you could, how do you say I want to react to this pattern in a stream and insert that in a static part of my database, for instance? I didn't understand the syntax at the beginning on that. Did I make my question clear or not?
Yes. So basically, yes, we do support static and streaming. Maybe the RSP part, RSPQL syntax, basically the RSPQL syntax is related to the streaming part. And for that, I will go back, maybe it will be more clear. So this is how we defining, and this is, so we have this R stream. So basically by this keywords, we defining if it's related to the static, basically data set, or it's related to something related to the streaming. And this is basically how you define everything. So
just yes, for me to understand here, on this example, you are on an R stream, so you're making a report, right?
Yeah.
And so the result of your construct here is something that you trap then in the API or through an event. If I want to make an insert, for instance, can I do that? If I want to insert something in my database as a report to an event in my stream, can I do that?
Yes, it's possible to do, yes.
Okay. Thank you. Very nice work.
Any other questions? Yes, Ruben.
So really nice. One thing I was wondering, so in the inputs and machine learning models, you use variables, right? And which are bound to the actual value of the inputs. So let's say you want the embedding of an entity as an input. How would you handle those types of inputs? Would you need to make the embedding in the stream side, or can you also make that in Kolibrie itself?
Could you a bit clarify?
Oh yeah. So, for example, you could embed knowledge graphs and get a vector that represents an entity. Could you also pass vectors as inputs through those variables, or how would you approach this?
You mean during the learning part, or you mean the output that we already have? Because the output, it's already the RDF tuple, basically, and then you can put it, I mean, as I said, to the query if it's needed, or to the rule, to then reasoning on top of that.
Mm-hmm. More like as input to the model too. So you have features which are derived from a stream.
Yes.
But let's say you have a model that sort of embeds those features, or like embeds entities, which are not necessarily numbers, but it embeds them into vectors. Could you also pass vectors into the model in Kolibrie?
Under the hood, yes, it is represented as a vector, yes.
Okay.
Because so basically, if we're talking the Rust, this learning part, we're using the Candle framework, and basically there it's something similar to PyTorch, where yes, everything will be represented as a vector, and then you train on that, and yeah. But it's under the hood, yes. You cannot like explicitly, you will not see it explicitly, only yeah, the engine itself does that. Yeah.
Cool, thanks.
Any other questions?
Yeah, I'll ask my question. Can you hear me clearly?
Yes.
Quite far. I was wondering, if I looked at your reasoner, it's if you can go maybe to that slide again, of where you give an example of your reasoning. Yes, here. For me, it looked a lot like this new spec there is, SHACL rules it's called. I was wondering if you maybe got your inspiration there, not necessarily that, but if you knew about it firstly, and if not, if it's this framework you made here, if this is something you came up with.
Currently, it's planned to support in the future the SHACL rules. Currently, we don't have, but in our plans to support and to have.
Yeah. Okay, then maybe a follow-up question. If you are planning to support SHACL rules, is this also a plan to support other reasoning frameworks like IDLab, for example?
We have the ideas to basically take some ideas from the iReasoner, and but like to have the bridge between Kolibrie and iReasoning, probably not.
Mm.
We'll see. We currently.
So maybe if I quickly may, so I supports N3, and so I is just a reasoner that supports the N3 logical fragments, let's say. We already support like a subset of N3, and in the future we will aim at least to support the whole N3 logic. So in that sense, yes, there is a connection between I and N3, given that we aim to support the same logic.
Okay, thank you. I was just wondering.
All right, good. Maybe one last question. At some point, you mentioned that you used RDF star quoted triples to represent something. I don't remember what exactly. Related to that, are you planning to implement support for RDF 1.2 and SPARQL 1.2?
Yes, but it's also in our future. Currently, we're using this for the probabilistic part reasoning, because it goes then to the learning part. That's why we decided to cover the RDF star. Yes, we in plans 1.2, but there's a lot of things to work on, and yeah.
Yeah, I understand.
Yeah.
Yeah, indeed. Implementing a SPARQL engine is a lot of work, and then if another version of the spec comes out, it's even more work.
Yeah.
That's true. Right, good. Unless there are any final questions. No. Okay. Let's. Thanks again, Lado, and feel free to stick around. And we'll go over to the other speakers of today.
Let me stop the sharing.
Yes. Just look into sharing my screen then. Just a moment. No, that way. This one. Share. There we go. Screen should be visible now. I suspect. Yes. All right. So the next person in the line is Ruben. Over to you, Ruben.
All right. My high-level goal is still the same. It's trying to optimize link traversal queries by using the fact that a single engine is sort of bound to a single user, so we can do client-specific optimizations in many forms. This month, I've worked on my rebuttal for an ISWC paper. I think, can we go next slide? Yeah. So I submitted that one. I'm not too sure how well that will go, but let's hope. There's always a chance. And then next up, for an extension of that paper or a journal paper in itself, I implemented more caching approaches, which is a form of client-side optimization, where I used a disk-based cache, and it is a store instead of just singular entities that I cache. So all the data is aggregated on disk. Then to reflect the same approach, I also did an in-memory quad store-based caching implementation. I added a cache that stores traversal information. So before you use a cache entry, you also check if it's actually reachable according to the current query, which should improve estimation performance and cardinality estimation performance. And then I have a work in progress which caches characteristic sets and pairs of documents, and then wants to use that for query optimization. It's a work in progress because I'm not too sure how to do property paths with characteristic sets and pairs yet. So because the deadline for a journal is coming up, I already started running the caching experiments I already implemented. That took a while because obviously there were mistakes I made in my code, but they seem to be running properly now. And then I had a project where I needed to make a proof of concept for a triple store for Flanders government, which I finished today, and that was also a lot of my time. So next month is much of the same. I want to finish those journal experiments that I mentioned before, where I experiment with the new caching approaches, but also because there's a new benchmark that is a part of the journal paper, I want to do some hyperparameter analysis of the benchmark I made. And the benchmark also consists of a refinement pattern generator or applier to the queries. And I want to analyze what the different refinement patterns I've defined do to query performance. So that's another experiment to run. Then I want to work on a proposal for working on link traversal to make it sort of production ready instead of just a research tool. And that will be for the Sovereign Tech Fund proposal, which I still need to think about how to actually approach this. So it's starting to work on. And finally, if I have time left this month, which may be doubtful, I want to restart working on derived resources, which is still going pretty well. I just need to find time for it to actually get to finishing it. But we'll see if it's this month or next month.
Okay, sounds good. When was the deadline again for the journal?
Well, ISWC will be 16th of July, so I want to at least have a draft ready around that time, so we can also still look at it but the deadline for the journal is the 31st of July. But I'll also be on holiday, so I don't want to have to do a lot still for the paper.
Yeah. So I guess in 1 or 2 weeks.
Yeah.
We should finish it. Yeah. Okay. Right. Any other questions for Ruben? Yes.
Yeah, I have a question regarding the disk storage. You mentioned that. Did you implement from scratch by using LSM3 or other algorithms, or you used like RocksDB, something like that, already existing framework?
Yeah, so I used existing code. It's called QuadStore on GitHub for TypeScript. And I think they use something like LevelDB or some form of backend that already exists to sort of use as storage. So it's pretty fast.
Okay, thank you.
Yeah, the advantage of LevelDB is that it also works in the browser. So it's compatible with browser APIs.
And for another question, in terms of indexing, like what kind of, how do you support if it's under the hood there? It's LevelDB, so I assume that they have something different now, or how you process that?
In terms of, do you mean like SPO indexes?
Yes.
I'm not sure how they do it, but they do have, they do allow you to define these SPO indexes. They do have it somewhere in memory, probably, maybe over I'm not sure how they do it exactly, but they do have those type of indexes.
Okay, thank you.
Okay. Unless there are any final questions, let us move to Brian.
So my high-level goal is to optimize the centralized query using explicit data publication structure. So it hasn't changed since. We can go to the next slide. So, sorry, this month I finished writing a paper on query containment for federated queries. However, we changed the target and we want to add some empirical experiment. So the work is just going to wait for it a little bit. I've also finished the response of my review for the paper I submitted for the Semantic Web Journal. And I've also almost finished the renovation for the large RDF benchmark. So basically the problem is that if you're using a standard query engine, the underlying RDF data is not valid, so you cannot perform queries over it. So I'm also starting to write a paper on the topic. And something that I haven't written here is that I've also almost finished an NLNet proposal. Can go to the next slide. So for this month, I'm planning to submit a paper about the renovation of this benchmark, and I'm planning to also finish my experiment for a work that I'm doing using Shape to optimize SPARQL federated queries. And that's it for me.
Okay. Any questions for Brian? Yes.
Yes, I have a question, but maybe a more understanding. What is a federated queries?
What is a federated query in general? You mean?
No, there's federated queries. What is the federated? What's the difference between normal queries and federated queries?
Federated queries is over multiple SPARQL endpoints or over multiple interfaces. So instead of just having one endpoint, you have multiple that you declare inside of your query, either with the service clauses in the SPARQL specification, or you can also use what we call automatic source selection. So you just provide a set of an endpoint, and then the engine will automatically figure out to which endpoint send the different input patterns, all the different operations.
And for the policies you mentioned, it's like in the RSPQL, in the same way you using those policies, or it's a bit different?
I don't know what is RSPGL, so I have no idea.
So basically, there is a possibility like to have like how long it must be something like the data contained in this windowing or something like that. So, and there's different ways of different policies related to that. So you have the same thing, or it's a bit different? I have never used federated queries, and that's why I'm asking.
Because the goal of federated queries is that you have multiple knowledge graph, and so you want to query the Wikipedia and Wikidata, and you want to perform one query over the two. So it's a mechanism so that you can do it without downloading all the data or doing something very ad hoc.
Yeah, and the challenge is, like in contrast to traditional SPARQL querying, where you optimize for a single index, in federated querying, you optimize over multiple stores or indexes, essentially. So you don't only need to optimize to reduce the amount of calls to your index, but you also need to optimize for reducing the amount of HTTP requests you do to endpoints, because a federated query is done over the web. So HTTP requests are quite expensive. So you need to reduce the number of HTTP requests, but also the response sizes of these HTTP requests. So yeah, the optimization criteria for federated queries can sometimes be quite different compared to normal SPARQL queries.
Okay, I see now.
You also have less access to statistical information about your data set. So usually you either have some sort of summary, or you perform multiple like common queries, some sort of analytic query to kind of figure out the data model inside of the endpoint, and a little bit of root cause analysis.
Oh, that's cool. That's cool.
But if you think about it, yeah, these kinds of federated queries are maybe in a way similar to RSPQL, because in RSPQL you can also have multiple streams, right, that you're querying over. So in that sense, it's also a form of a federated query, but it's over streams.
Okay. Very interesting.
All right. Any other questions for Brian? No. Okay. Then we can go over to Lander. So Lander has been working for us as a job student for the last couple of months, and since he's done such a great job, we let him briefly talk about his work.
Thank you very much. Thank you for the compliment. I appreciate it. Yes, so I worked as a job student for the past 5 to 6 months, a day a week. And my goal is to add, there's this new spec called SHACL. Is it something that is relevant? Is it something relevant? Will this be the new thing? Because they want this to become a spec. Yeah, it's a drop now. So it was interesting to look at. It's a reasoner. So what I've been doing is, so I started making a parser for this. I've used the Ghent's traversal. It's a very optimized and very modular way of defining an AST tree and an algebra. So I use that. And what I've done is I made an npm package for it. So now there is an npm package that parses SHACL rules. Then the next thing was to make an engine for this. Okay, SHACL rules. If you look at it, it looks awfully a lot like SPARQL. So why don't you use the SPARQL engine? Why don't you use Communica, which is also optimized? So what I did is I made in Communica, again, a subset from Communica. I made an engine for it. And so now there is a SHACL rules engine that is based on the Communica engine, I guess. And then, okay, now we have this reasoning. So I made a little demo for it, which I can show you.
Yes, I'll just stop sharing for a moment, and then you can share.
I hope it will work. It's not.
We can see ourselves.
Okay, then it works. Well, it was smart. So just if you want to play around with it a little, then this is the link for it, but that's okay. Yeah, very easy. So you can, again, as we've seen in Kolibrie itself, let's use the SHACL rules grammar, which when you have to refine your data, which is not, everyone is not a fan of this. Why can you not like insert a knowledge graph, for example, and query a knowledge graph? No, you have to define your data explicitly. And then indeed, there is this rule, which you saw in Kolibrie, which is the then, and then the where is the if statement. So yeah, this is the demo. Yeah, you can run it, and then your blue triples will come down here. And just, I want to talk maybe a little bit to show you how modular it is, how easy it is used. So this is my npm package, which I made in Communica. And then if you want to reason over it, you just make a new engine, which you do here. You will, if I see, if I engine, yeah, here's where it queries. You just add your query itself, which is written in SHACL rules. You add a source, your destination. This is also not really spec related because the spec doesn't say that you add your triples again to the store itself. It lets this open for you. And so now you have a stream of reports. And so, yeah, this was my little demo for it. The goal was to, is this now something we can all use? I think it's just another framework for reasoning, like there was with N3, like there was with I. It's nice that this is so based on SPARQL, I guess.
Yeah, indeed.
The future.
Yeah,
for this, yeah.
Yeah. The big advantage, as you say, is indeed that it's very related to SPARQL. So grammar-wise, there's a lot of overlap. So you created a new parser for SHACL rules, but you could easily reuse most of the grammar or the parsing logic from what we already have in SPARQL. So it was not a lot of work to create the parser, I assume.
And it's also with SHACL, it supported this, and it was 90% the same as SPARQL, and then with SHACL it was very plug and play. So that's also something.
Yeah. And then for the actual evaluation of the SHACL rules, you could also reuse many components of Communica.
Yeah.
Like Communica at the moment consists of, I think, almost 300 modules. Like, how many new modules did you have to create now for
two actors, not just actors. Yeah. Two actors, that one for parsing, and then one for the engine itself. That was it. Basically, you could split this up. I think it's also nice with Communica if you have some new, you want some new ways of using it. Like you want to add it to a store, but someone doesn't want to add it to a store. I think with Communica, it's an easy way to just find new active, new engines. Then, so you could make more modules, but for the basic one, two was the only ones I needed.
Yeah. So yeah. It's So if you already have a SPARQL engine implementation, making a SHACL rules one is not a huge amount of work. Is what you found.
Yes, that's quite a good conclusion. Yeah.
Yeah. Okay.
Okay. Thank you.
Very nice. Any questions for Lander? Yes, Mike.
You didn't add any actors, so you just used the normal SPARQL operators that are in Communica, I assume.
Yeah, it looks a lot like a construct. The rule statements, it's a SPARQL construct.
So, it's a construct queries. Okay, I was wondering if it would be possible to slot your engine into Communica and now have an incremental SHACL query evaluator.
Probably.
Yeah.
Yeah. It just Communica doesn't support construct queries, so I would have to add the construct queries, and then it would be possible to do this. But yeah, okay, cool.
And yeah, construct queries are very easy to implement on top of select queries. So wait,
Indeed.
And don't like when the normal construct actor not work in your case?
I don't think it will produce a stream of, or maybe it will. Oh, it won't support the deletions. That's why it won't work probably. It will just duplicate everything if you have a deletion.
Yeah.
So, but it wouldn't be that much effort to actually implement it.
Mm-hmm. So yeah, you need a way to annotate the quads with addition or deletion, or you could serialize it as RDF 1.2 annotations.
True. But Ecommunica already has annotations for quads, for deletions and additions, because it needs it in the input. So I could just reuse that at the output. Yeah, cool.
Lado, you also have a question?
Yes, I also have a question. How do you handle termination when the rules recursively generated new triples?
Yeah. In the beginning of my research, I thought this was done very naively, and you just relearn everything. This was very slow, as you might think. But then I've talked to Jos. I don't know the full name of Jos.
Jos de Roo,
which had some very nice suggestions of algorithms, certification algorithms, to make this faster. There's also, I don't know if this answers your question. For me, stratification and the stratification algorithm answers your question. Which one I use? No.
What kind of? Would you?
There's a name for it, and I forgot it already. I think it's Kahn's algorithm.
Okay.
Yeah, is it Kahn's? Yeah. There's also one on the SHACL rule spec itself, but they also note that you don't have to use this one. So if you would look there, there's an evaluation algorithm, a stratification layer algorithm. So my idea was also to compare that and then compare it to the state of the art and why it just doesn't use those algorithms. Yeah, there's a lot of things you can ask on this topic. But yeah, I've not looked into everything. But yeah, it uses stratification now.
Oh, okay. So they have also something in the specification, some algorithm. Ah, interesting. Okay. I didn't know that.
Yeah, but the specification is changing quite often. I think around every 3-4 days there's an update on it. It's most of them are rather small, but yeah, it's changing quite quickly.
Okay.
Yeah, and even the name, they're not certain of yet, I heard. Because there was this meeting yesterday where they discussed the name, but from what I heard, they don't have a conclusion yet. Because yeah, it's called SHACL rules, but it's very related to SPARQL. So yeah, might make sense to rename it to SPARQL rules because it doesn't have a direct relationship to SHACL, at least at the moment. All right. Any final questions for Landers? No. All right. Yeah, you stopped sharing, so I can share my screen again. Just a moment. Again. All right, my screen should be visible again. All right, then over to me. So yeah, my goal is still the same. I want to support the PhD students in their research here. So what I worked on in the past month, at the beginning of the month, I attended this Goblin hackathon in Spain, where we had a hackathon on the topic of metadata in RDF 1.2. So yeah, we worked on a bunch of things. The group I was mostly involved in, there we focused on investigating how you can represent RDF 1.2 data in labeled property graphs. So usually the reverse direction makes more sense. Like it's very natural to represent labeled property graphs within RDF 1.2, which is also one of the motivations for creating RDF 1.2. But we wanted to investigate the reverse as well, because RDF 1.2 is more expressive than labeled property graphs. So it's not immediately clear how you would represent certain things from RDF 1.2 in labeled property graphs. But eventually we came up with several different approaches, each having their own pros and cons. And we also made some prototype implementations. So yeah, the plan is to write some kind of short paper out of this, maybe a workshop paper for the DMKG workshop. But yeah, we haven't started writing yet, so yeah, we'll see how it goes. Maybe we do it at a later point in time. That remains to be seen. Besides that, I also wrote a workshop paper for this AMW workshop later this year on the topic of fragment selector shapes. So this is something that has existed within Communica for a while already. So it's essentially a mechanism that allows you to express. So it's essentially a language to express the expressivity of query interfaces. So for example, if your data source is a SPARQL endpoint, this language allows you to say, this is a data source that accepts all possible query shapes that you can express in SPARQL. But for example, for the triple pattern fragments interface, the shape would look a bit different. In that case, the shape would basically just say, this data source supports triple pattern queries. But then you also have interfaces like BRTPF, which is an extension of triple pattern fragments, where you can say that this interface supports triple pattern queries and optionally also value clauses. So yeah, this paper basically formally introduces these fragment selector shapes and gives some concrete examples of different interfaces, how you would represent these shapes. So yeah, this was a paper I've been wanting to write for several years now, and I finally had some time for it. So yeah, that's under submission now. Besides that, yeah, there was also a lot of work for examinations of the web development course. Yeah, and then at the end of last week, I received news that my paper for the Blue Sky track and semantics was accepted. So yeah, if you want to read more about that, you can find a preprint on my website. Then my next targets, the RDF and SPARQL working group is still ongoing. Yeah, a bunch of work still needs to be done, but slowly but surely we're getting there. What I then also want to do, Bryan has done a lot of work in this direction already. I want to make it possible to make sure that within the CI of Communica, we continuously run federation benchmarks as well, because at the moment we only run WHAT-IF and BSBM, but it would be good if we would also run large RDF bench in there, which should now be a lot easier thanks to all of the work that Bryan did. And what I also want to do is, so at the moment we do this continuous performance tracking, but I also want to make sure that we have something similar for pull requests, so that if someone creates a pull request, that you immediately see performance is not impacted with this pull request, or you can see performance degrades by 20%, something like that, so that we can immediately see the impact of performance on changes in pull requests. Yeah, so that's my next target. But yeah, holidays are coming up, so yeah, probably not a huge amount of work can be done. Yeah, and that's all for me. Any questions? Yes, Martin.
I know you wanted to do the performance tracking before, but weren't able to because the GitHub Actions just selects random machines, so there's no consistency in what is running them. How are you planning on solving it now, then?
Well, that is still the case. Like at the moment, also in our in the performance tracking we do on the master branch, for example, yeah, different machines can still be selected. So there is some variance. Like if you look at the graph, there is some variance, but it's not too bad. Like we know that there is some variance, so we cannot trust the numbers very accurately. But we can still see the impact of big performance regressions or improvements. Like there have been multiple instances already of changes that we did, either positive changes or negative changes, where you really see the impact on performance. Like if something suddenly becomes 10 times slower, then you will see it. Like the variation, like the normal variation is something like maybe 5% or so in execution time. So if the impact on performance is higher than 5%, then you will see it. But the reason why we didn't do that for pull request yet is because the GitHub Actions system has no native support for it. So yeah, I would need to implement something custom, but I think it's worth it to do. Because yeah, sometimes for pull requests, sometimes I manually need to run the performance benchmarks, and it would save a lot of time if that would go automatically.
Okay, thank you.
Yes, Brian.
I was wondering, yeah, at least you said that 5% was the reasonable variance. Can you have a system that if it's more than 5%, then you rerun it multiple times and you check if it's still 5 within this 5%? Or maybe just try to tell the person who's making the PR that they need to provide a proof that they, to run it themselves, basically on their machine.
Yeah, we could do that indeed. Like if we're not certain about the CI-based measurements, then indeed we could ask the PR author to run it themselves.
Okay, so it will become some sort of flag, like there's a requirement that the unit that's passed, it will be something like that, maybe.
Yeah, that's the plan. I'm not sure yet how it will look like exactly, but something like that will probably be in place.
That's really cool.
Yes.
Yes, I have also a small question. Those this fragment shape that you mentioned, those shape-defined fragments could be treated as a basically materialized graph view, or not, or how?
Yeah, not really. So these shapes are not data. They basically refer to SPARQL expressions essentially. So these shapes basically represent something like or are basically, for example, a reference to the triple pattern operation. So a shape that only refers to the triple pattern operation basically says, this data source accepts triple pattern queries. Or you could have a disjunction as well, a disjunction between triple pattern and union. Which would mean you can do triple patterns on this query interface, or unions of triple patterns. So things like that. Does that make sense?
I guess so. So it's something like similar to what, okay, wait, but is it similar to like the SHACL that has something similar? I also know, or
Well, it's inspired by SHACL, but the thing is, SHACL defines data shapes, but these fragment selector shapes define query shapes. So it's a shape, both are a shape, but shapes for different kinds of things, essentially.
Okay.
So the problem that these fragment selector shapes try to solve is like in practice, we have different kinds of query interfaces. And within Communica, for example, we try to make it possible to query over all of these different types of query interfaces without the user having to know what type of interface this is. So the goal of Communica is to be agnostic of the types of interfaces and to automatically optimize the query based on the expressivity of this interface. And using these fragment selector shapes, Communica can do the detection of the expressivity of this interface automatically. So that's the need for these fragment selector shapes.
Okay, I see now. Okay.
The endpoint, SPARQL endpoint has such a selector shape.
Well, no,
that's the point. That's the goal.
That's the goal. Okay. Yeah. So right now these fragment selector shapes, or at least in the paper, I introduced them formally, but we don't have a syntax for it yet. Like in Communica, we have a TypeScript-based implementation, but we don't have a syntax yet, so that a SPARQL endpoint, for example, can announce it. So that would be the next step. But I don't think it should be too difficult to represent. But yeah, that's future work.
Interesting.
All right. Then I guess we're almost done for today. So our next progress update will be in 2 months. We won't have one next month because most people will be on holidays. It doesn't make sense to have one when no one is here, of course. So the next one will be on August 25th, again at 9:30. All right. Thanks all for joining, and especially also Lado and London for your presentations. And see you all next time.
Thank you. See you.
Bye bye.
Thank you.